Geometry students, let's do the homework on counting. It's not probability. It's like going to help us with some more complex probability, but we're just going to count the weights. We start with the easy understanding that if you're like have multiple options, you want to multiply for all of your total options. So if I have a waffle or cake cone, I have two options for the type of cone. Then I have one, two, three different ice creams. And then I have 13 different toppings. So if you have to choose one thing, like one of the cones, one ice cream flavor, and then 13 toppings, you have two choices. And then you'd have three choices off of those two choices. And then you'd have 13 choices. You're only allowed to get one of those. Uh, Obviously, you can get more than 13, more than one topping usually. You can get like one topping, or you can get two toppings, or you can get three toppings. And that would be a lot more possibilities. So let's just assume you can do one topping. Well, I appreciate the email. I'm very excited, very happy and honored you chose me. Okay. Corey's mom does not like strawberry. So that means she's got two choices of ice cream. She can only have one topping. Uh, if we considered you could have 13 toppings or 12 toppings, it would get a lot more complicated. Dad only likes strawberry, so two, one choice for a thing, and then it's very important to say that one of this many toppings. Shop has 12 flavors to choose from. Customer wishes to order their largest ice cream cone. On this ice cream cone, each flavor is stacked one on top of the other based on the customer's preference. How many different ways can the customer choose the order of ice cream? Well, this is the idea behind the introduction of a factorial. We got 12 choices for the first ice cream on top of the cone. So here's our ice cream cone. And then we have our first ice cream can be one of 12. And then the next ice cream will have 11 flavors to choose from. And the next is 10. And then we're going to go all the way down to one. Now that takes forever to write out. So what we do is we use this factorial. Factorial just means 12 times 11 times 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. We're going to leave that answer like that. Cool. That's how many options that customer who's ordering all 12 of the ice creams has. A different customer is grossed out by the previous customer's order and only wishes to get 3 scoops of ice cream in order of their preference. So she wants to make sure that bottom, middle, top matters. If you have chocolate, vanilla, strawberry, that's going to be different than strawberry, vanilla, chocolate. So like order matters. This one on the bottom is matters where it is. So they'll have 12 choices for the first scoop, 11 choices for the second scoop, and 10 choices for the third scoop. Now, what is a way to write this out using factorials? Well, that's 12 choices times 11 times 10. So I'm not going to use 9 of the flavors, right? That's the idea. It's like I just have 12, 11, 10, and then the other 9 flavors I'm not going to choose. So think about 12 factorial. 12 factorial is 12 times 11 times 10 times 9 times 8 all the way down. But I don't want the 9 and the 8 and the 7. So I will not use 9 of those flavors. I'm going to divide by 9 factorial. This is called a permutation. Cool. Now, a third customer just wants to get 3 scoops of ice cream into a cup, but they don't care the order in which they are placed. So, like, if I choose chocolate, vanilla, strawberry, it is the same as if I choose strawberry, vanilla, chocolate, or chocolate, strawberry, vanilla. So, how do we consider that? Well, we have our 12 factorial over 9 factorial three orders, three scoop order possibilities. However, let's say I ordered chocolate, vanilla, and strawberry. There are 6 ways to order that chocolate, vanilla, strawberry that we would consider the same. And then let's say I did like cookies and cream, mint chocolate chip. That's my wife's favorite. I'm a cookies and cream. Salted caramel is another one of my favorite. Dark chocolate sea salt, another one of my favorites. Let's say I ordered those 3. There's 6 ways to order those 3. 3 choices for the first and then 2 for the one. I need to kind of like remove all of those possibilities so they just count for 1. This is why we will divide by all of the combinations of the 3 ways, of the 3 scoops that we want to count for 1. It's very hard to explain, but we are going to like divide by the repeated choices. So it ends up being the answer we got earlier, but then divide out the repeated possibilities. You could write it like this. You could also write it like this. It's the same. And this is what we call a combination. Sorry, this is 12P3. This is 12C3. Okay. And you'll see there's a lot more ways, 6 times more ways for this compared to this. On a combination lock, the code can have 3 numbers and there are 40 numbers to choose from. Okay, cool. 0 to 40. 0 to 39. So including 0, those would be 40. If the same number can be selected more than once, how many possible codes can there be? So 3 numbers. We'll have 40 choices for the first, 40 choices for the second, 40 choices for the third. 40 times 40 times 40. Same cannot be selected. 40, then 39, then 38, which we can say is 40 factorial, but get rid of the other 37 slots that we don't want. We just want 3 slots. So 40 factorial divided by 37 factorial. Different combination lock will open if you pick 8 numbers, but it does not care about the order in which you select the numbers. Okay, so we will start with 40 times 39 times 38, all the way until we get down to 8 numbers selected. So if I get 8 numbers selected, I'm going to end at 32. So 1, 2, 3, 4, 5, 6, 7, 8. 6. Well, I'm going to end at actually 33. Which means if I take 40 factorial, I want to divide the 32, the 31, the 30. So I'm going to get rid of those 32 other numbers that I'm not selecting. Cool. However, every time I pick 8 numbers, if I pick 1, 2, 3, 4, 5, 6, 7, 8, or if I pick 8, 7, 6, 5, 4, 3, 2, 1, they're going to be the same code or the same combo, which means I need to divide out all of those ways to pick the 8 same numbers, which is 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And this is a combination. I have 40 numbers to choose from. I'm choosing 8 of those numbers. But I start with 40 factorial all the way down to 33. But I want to remove the repeat orders. So I take that and divide it by all of those 8 factorial ways to choose 8 numbers. You can write it like this. You can write it like this. Texas car license plates consist of 3 letters followed by 4 digits, assuming that all possible combinations are allowed. How many possible license plates could be? So I'll have 25 letters 3 times, and then I'll have 10 digits 4 times. So that'd be 25 cubed times 10 to the 4th possible ways. The student Patrick wants to have the letters in his name make up his license plate, so he's going to rearrange them. How many different possible combinations of his letters are there? Well, there's a total of 1, 2, 3, 4, 5, 6, 7 letters in Patrick. So he'll have 7 of those letters to choose for the first spot, 6 for the second, 3 for the third, etc., all the way down to 1. So that is 7 factorial ways for Patrick to pick out letters for his name. Ashley has a long name. She just wants to pick out 4 letters from her name. She doesn't care the order in which the letters are placed. So how many different 4-letter combinations are there? So she just wants right now to pick out 4 letters that she wants. And we're trying to figure out how many possible combinations that there are. If I pick ASHL, that'll be the same as LHSA. Right now, she's just kind of choosing 4 letters that she will then arrange. So this is the idea that of the 1, 2, 3, 4, 5, 6, 7, 8 letters, she's going to choose a group of 4, not caring about the order. So that's going to be the 8 factorial ways for the 4 spots. So I have 4 spots that I don't want that I'm going to remove. So that's 8, 7, 6, 5, 4, 8, 7, 6, 5, and I'll remove the 4, 3, 2, 1. But I want to remove all of the repeated possibilities of ASHL or SHLA. So all of those 4 times 3 times 2 times 1 ways, I want them to just count once. I'm going to divide by 4 factorial as well. So that's 8 factorial divided by 4 factorial times 4 factorial. 4 factorial times 4 factorial is not 8 factorial. So she doesn't care the order. We have a combination. We want to remove the repeated possibilities. So, okay, 10 choices for the first, 9 for the second, 8 for the third, 7 for the fourth, which is the idea of 10 factorial over 6 factorial. I have 10 choices. I'm choosing 4 slots. Order matters. So that's what I have. TV channel has 6 different 1-hour shows to fill 2 hours of time. Order will matter. Well, I wonder if order matters here. I guess program lineups mean order matters. The first show versus the second show. Back in the day, it used to be like Seinfeld followed by Friends. That order mattered. That was Thursday nights on NBC. So we're going to say the order matters. So we want to fill 2 slots. I'll have 6 shows for the first, 5 shows for the second. That is 6 factorial, removing the 4 factorial shows that I don't want, all those choices. That is 10, 6p2. On a rugby team, 15 players are selected to play at a given time. A coach of a 24-person rugby team wants to select who they think are the 15 most athletic players and have them start regardless of their position. How many ways can he select 15 players? So that means selecting 15 players, like 1 through 15. Let's say they're numbered 1 through 15. That's the same as picking 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 1. So this means order does not matter. Order does not matter. So that means we have to remove all of those different possibilities. I start with 24, then I have 23, then I have 22, and I'm gonna go all the way till I've picked 15 players. So that means I need to figure out what I go to. 9. So I have 9 players that are not selected. So I'm gonna end with 16. Whoa, I'm starting to get all confused. Okay. This one's tricky. So 20, 24, 23, 22, 21. We have 9 extra slots remaining. So that means we're going to go to 10. There we go. That's what I was thinking. So we're going to go all the way down to 10. So that's picking 15 players, which means I have that 24 factorial, but I got 9 players that are not going to be selected. Cool. However, when I pick a group of 15, and if you pick them a different way, we don't want to count all those different ways. How many different ways are there to select a group of 15 players? Well, there's 15 factorial ways to pick a group of 15 players. You need to remove those 15 factorial ways to pick the same group of players. Or you got this 20 factorial divided by the 9 factorial that you're not picking and divided by the 15 factorial repeated ways to pick 15 players. This is a combination. This is 24 choosing a group of 15. Oh, this is a true story. I wrote this. I met the bronze medalist at the 2020 women's marathon. She's very nice. She's very hardcore. Like, to be an Olympian marathon / Olympian in general, you have to be crazy. But she was very nice, but you could tell she's like a dedicated runner and very impressive person. 88 female competitors in the race. True story. How many different ways could 3 different competitors win a gold, silver, or bronze medal? Well, 88 could win gold, 87 could win bronze, silver, 86 could win bronze. Cool. This is the idea of 88 choices, the permutations of 3 medalists. This is the same as 88 factorial divided by the 85 people who don't win a medal. Okay. 100 juniors, we're selecting a committee of 8 students. So we want to just choose a group of 8 students. We don't want like students A, B, C, D, E, F, G, H. If I select those students, I can't select H, G, B, A, like if you select the 8 students, all the different ways of selecting those 8 students need to be removed. So we just choose them once as one group. Well, so we have the 100 times the 99 times the 98, all the way down to 93 for the 8 spots. So then we need to divide by the 8 factorial ways to get that. That is the same as that 100 factorial divided by the 92 students who are not selected, but also divide by the 8 factorial ways to pick the group of 8 that are repeated groups, which we don't want. So we want just one of those groups to count, which is the same as this. Okay, hope you understand. Counting is fun, and hopefully understanding counting is a lot harder than just like using formulas. So I hope we're understanding what's going on. Peace.